Let's take a look at an example of average rate of change. Average rate of change is slope between 2 points on a secant line. It's sort of connecting those things with a straight line, and it's figuring out what's going on over that interval. So this says, suppose an arrow is shot upward on the moon. We've all been in that situation where we're shooting arrows on the moon with a velocity of 61 meters per second. Its height after t meters is given by the equation 61t minus 0.83 t squared. That 0.83 is actually kind of an interesting number. We'll see that at a later date. Find the average velocity over the given time intervals. I've got on the side here Desmos open. I'm going to type in that function h of t is equal to 61t minus 0.83 t squared. The graph is pretty steep, but I'm actually not interested in the graph here. If I hit this gear thing on the side, edit list, I can create a table, and then I can change these values in the table. 3, 3.01, 3.1, 3.5, and 4. Okay, so I think I got all the values that I need there. These are all of the y values for 3, 3.01, 3.1, 3.5, and 4. So let's go ahead and find the average rate of change. I'm going to switch to my tablet mode, so my face is going to go away here. I would encourage you to pause the video and try this out. I'm going to pause the video as we switch views. Okay, let's look at average rate of change. Some people abbreviate that as AROC for average rate of change. You could also say it's the slope on average over that interval, or it's the average velocity. All these are kind of telling me the same thing. And this is rise, change in my y values, over run, change in my x values. So let's look at part A. This is on the interval 3, 4. So to find that average rate of change, we are going to subtract the x values down at the bottom here, b minus a. So that's going to be 4 minus 3. You could do them in either order, you just have to be consistent. And then on the top, I'm going to put the corresponding y values. So that's a y value of 230.72 for 4, using this table that I just came up with. And for 3, I have 175.53. I'm going to type this into a calculator and see what I get. On the bottom, I'm noticing that that is just the number 1, so that's kind of a nice denominator. And on the top, I've got 55.19. So my first average rate of change is 55.19. If we track the units, this is meters on the top, that's the position, and on the bottom I have the seconds. So this is giving me meters per second. It's giving me a velocity. Let's see what's going on in the next interval from 3 to 3.5. So what I'm doing here is I'm taking that endpoint of 4, and I'm just going to get closer and closer to 3. My goal here is really to find the instantaneous velocity, the velocity at the value 3. And I can do that by finding the slope and just getting closer and closer and closer. So on the bottom, I've got the change in my x values, 3.5 minus 3. On the top, I've got the change in my y values. I'm using my table here. I have 203.3325. And at 3, it's still 175.53. I'm going to type that numerator into a calculator. I get 27.8025, which gives me an average velocity of 55.605 meters per second. So actually pretty close to that last average velocity from 3 to 4. Part C says find it from 3 to 3.1. So let's do that. My average rate of change, my average velocity. I'm looking at the change in my x values on the bottom, 3.1 and 3. Change in my y values, 181.1237, using that table. Thank you, table. And that y value of 175.53 for 3. So again, I am subtracting the top there. 5.5937, dividing that by the denominator, and this is giving me 55.937 meters per second. So it looks like this might be getting closer and closer to a value of, it's hard to estimate, but maybe about 56 or so. Let's see what's going on for this last interval from 3 to 3.01. Average rate of change is equal to, I'm looking at the change in my y values, using the table to get that 176.09 for that first value. Second value is 175.53. And I'm dividing this by 3.01 minus 3. I'm going to type that into a calculator. And that gives me 56.012, again, my units here, meters per second. So whenever anyone is asking for an average rate of change, think slope. You're looking at the change in your function outputs over the change in the inputs. So that's what it looks like for this particular example. Let's check out some more examples together.